right, so this is tutoring hours, and Johnny Figueroa just asked a question, and there was something wrong with the audio, so I am re-recording it. Thank you, Johnny, for asking the question. I know you're gone now, but this is for you. Okay, so let me show you my desk. There it is. And let me get closer. Okay, so the question Johnny had was he need a little bit more help with the homework. Okay, and I already done it, so now I have to cover it up so I can walk you through it. Okay, so remember that you have to start with a balanced equation. So we worked on that. Let me freeze the focus. There we go. Okay, you have to start with a balanced equation. And I think most of you got that down pretty well. And then you're going to use this chart. Now, you can answer this question. You can solve the problem that's given without using this chart. What this is going to help you do is to realize what is happening to every single substance involved in this reaction. And if you learn this method, it's going to be a lot easier for you to solve the harder stoichiometry problem. They won't even be, excuse me, hard for you when we get there. If I teach you the normal way of doing this, then when we get to other problems, it'll seem like it's getting harder and harder. Okay, so we're going to start with this. It's going to answer a lot of questions that the problem does not ask you, but by doing it this way, you get a really good feel of what stoichiometry is, and you'll be more prepared for future problems. Okay, all right. So the before line, by the way, you're keeping track of all these amounts right underneath each one of the reactants and products in the equation. Okay, so the first line is you're keeping track of, okay, what do we have before the reaction happens? Okay, this side of the problem is your reactants. These are your products. So reactants are what you start out with. Products are what you're going to make. So before the reaction happens, we already know we're not going to have any of this stuff here. And then we're going to look at the problem to see, okay, what do we have? And it says you have 8 moles of hydrogen sulfide. So we're going to go ahead and put 8 moles there. Okay, and you're going to completely burn it. So you're going to use up all of that, which means you're not going to have any left after the reaction happens. Okay, and then you don't know how many moles of oxygen gas. So we're going to put a question mark there for now. I think you can put excess or question mark. Either of those for now will be fine. Okay, now the next row is keeping track of, well, how are these amounts changing as the reaction proceeds? So we know that reactants get used up. That's why these are going to be negatives. And we also know that products are being made. They're increasing in amount. So we're going to put pluses in front of those. Okay, so what are the amounts here? Well, that is going to be what the coefficients are going to help you do. Okay, so we're trying to find this, and it's not as easy as the problems that I gave in the mole ratio worksheet example that we worked together. In this case, you might want to, if you can't do it in your head, you're going to use the calculations that I showed you. Okay, so in those calculations, if we're trying to find this, okay, let's try to find this. We're going to start with what we have. So we know we have 8 moles of this H2S. So we're going to write 8 moles H2S. And then we're going to multiply it by a fraction. That's going to help us to get the answer. And that mole fraction is your ratio. So if we're trying to find this and we know this, well, we know that for every 3 of these that we want to make, we're going to need 2 of those. It's a 3-to-2 ratio. And if you're having trouble remembering, well, would it be this one to this one, or would I use this one to that one? Just remember this saying, have over want. Okay, oh, I messed you up. Want over have. We want this. Want over have. Okay, want over have. I always want more than I have. Maybe that will help you. So want over have. I want O2, so I'm going to take this coefficient and put it on the top. And then I have, this is the information I have this, so that's going to go on the bottom. And your double check is, well, let's put the formulas next to the coefficients in our fraction. So the O2 goes with the 3, and the H2S goes with the 2, and then look, you can see how this cancels that, right? So if H2S cancels, what do we have left? O2, and that is what I wanted. So now we can do the math. So 8 times 3 is 24, divided by 2. 24 divided by 2 is 12. So that is the amount of O2 that's going to be used up if I start out with 8 moles of the H2S. Okay, now we can fill in the other changes for the products, and these are going to be easy because the coefficients are the same here and there. So that means these numbers are going to be the same. So we're going to put 8 there, and that is also 2, so 8's going to go there. And then we do the after. So what do we end up with? If this was our starting amounts, what do we end up with? Well, we know we used up all of this. Okay, we didn't know how much we started out with. This must be excess because this is oxygen from the air. So we're going to have excess here. We can put a question mark. And then we didn't have any. We made 8 SO2, and the same thing with water. Okay, and then now we're just going to go back and make sure that we answer the question that was given. How many moles of oxygen gas would be needed to completely burn 8 moles of hydrogen sulfide? That's this one right here. So we're going to block that in, and that's our answer. Right now, the second one, I'm not going to work out for you, but I wanted to point out a few things. This one here is giving you the product. So if 12 moles of carbon dioxide are formed, okay, that means we're making 12. We're making 12 of these. Okay, then how many moles of propane are burned? So this is what we're trying to find. Okay, now we're not going to put the 12 here because we know it's a product. And in the beginning, before the reaction happens, these are going to be zeros. Okay, so this is what we have. We're trying to find this for the question. I want you to fill the whole thing out, but to answer the question, this is what you need. So when you do your calculations, remember you always start with what you have. And then this is going to be a want over have ratio. So to find this answer, it's going to be want over have. So when you balance your equation, whatever the coefficients are, it's going to be that coefficient divided by that coefficient. Okay, if you're trying to find this answer, then it's going to be want over have. Remember, this is your have. So it's going to be a different ratio depending on which one of these you're trying to find. Okay, and that's it. And hopefully this recording doesn't have that weird fuzzy sound.